Oh, I apologize. My name is
There's a snake in my. So if everybody would come in here a little close, real close, and take a look. Look and see where these taps are. This winding that's on the outside here, this is the high sets of windings like I talked about. It was the primary. And then inside, those windings are the secondary windings. And there's an iron core right here that helps enhance that magnetic field. This whole thing is on an iron core that runs in the center of all the windings. Right? So if you look here, this bar, this is the XO. See how it says XO? And this is all coming down to right here. So there's one place for me to land the neutral, and there's another place for me to land the GEC. So you see this lug right here that I was talking about with the grounding, and this lay-in lug, this is what I usually put the beaver tooth in, because I like to be able to, if it's a bigger wire, I don't want to have to push it through that lug and leave it long enough to make it. I can just lay it in there. But we're still never want to break that wire if we can avoid it, right? We just want to be able to bring that GEC. Now this GEC is coming from building steel and this driven electrode. It's shown right here. I don't know if there's water pipe available. Here's water pipe. See, so it already has all the clues for what it is that we want to do. And in this case, it would be real easy, like you said, to take one wire and bring it through building steel, bring it through this little clamp, bring it up here and have it land right there. And you would be able to pick up all three and use that one. And then where does it land on here again? XO. Why? Because we've got to have that zero reference, right? We're making that zero reference. So if you look on here, like we talked about before, H3, H1, and H2, these are the taps that we talked about. And you would use more or less windings depending on what voltage you need. You can put winding, you can move this lead up and down. Like I said, I rarely do it. I think I may have done it once in my entire career, 30 years. Usually the factory, it's all fine and dandy. But it's good to know the theory, right? So then we got these, and this we're gonna bring, this is our primary, right? We're coming through here, and this ground has overcurrent protection. So we're using 250, 122 here, because it has overcurrent protection. We know there's only a limited amount of current that can actually be produced from here. But when we go on the secondary side, we have to use the size of the wire, because basically the wire is a fusible link. And we have to size the ground according to the service entrance conductors that are coming into this new service or a new separately derived system. Okay. So it's pretty cut and dry, but I just wanted to kind of show you the different parts.
So this is something that we're going to get tested on, and you know what? I don't care about like grades about the test. This is something I feel like everybody in here needs to know how to do if you call yourself an electrician. The stuff that we are talking about today, I'm talking about from the mutual induction all the way to here. I expect for everybody to want to know that. Not to know it, to want to know it. I mean, if you could, Frank told me something at the break, it's like, it's what you're made of. So some people are gonna get it.
Well, some people, I didn't say they're not everybody's going to get it. Some people want to. Some people just want to run pipe, and some people, they just want to do it. They don't want to know the theory. They don't want to know everything that works. It's entirely up to the person if they want to do it.
But when you go to that building, and when